Welcome to the Explainer. Today, we're going to do something a little different. We're not just going to talk about a topic, you're actually going to step into the shoes of a cybersecurity intern and tackle a real-world mission. Your objective? To secure a modern, cloud-native stack right from the ground up. This right here, this is the core idea for our entire mission today. It's this principle that security isn't something you bolt on at the end. It's not about reacting to threats, it's about building your defenses into the very foundation of your systems before any bad code even gets a chance to run. That's proactive defense, and honestly, it's what separates the pros from the amateurs.
So, here's our game plan. First, we'll cover the fundamental security layers you absolutely have to know. Then, we'll look at what's at stake by checking out some major real-world breaches. After that, you'll get your official mission briefing, we'll walk through how to execute it, and finally, we'll look at the incredible impact you've made and the new skills you've picked up along the way.
Okay, let's dive right in. Look, to secure any environment, you first have to understand how it's built. We're going to be working with 3 critical layers of defense, and we're starting at the very bottom, right at the operating system.
Pretty much everything in the modern cloud, and I mean everything, sits on top of Linux. It is the bedrock. The great news is that the Linux kernel itself comes packed with some incredibly powerful built-in security controls that we can use to lock down our entire system. This is our first and most important line of defense.
Now, at the kernel level, these are the 2 heavy hitters. You've got SELinux, which you'll usually find in Red Hat systems, and it uses this super granular, label-based system. Think of it like giving a detailed security clearance badge to every single file and every process. Then you have AppArmor, which is common in the Ubuntu world. It's a bit simpler, using a path-based approach, basically defining what a program can do based on where it lives on the file system. Different methods, but the same goal: enforce really strict rules on what an application is allowed to touch.
All right, moving up a layer, we've got the container runtime itself. You know, Docker, Containerd, that kind of thing. Now, containers are awesome for keeping apps isolated, but they all share the host's Linux kernel. What does that mean? It means a single weakness here, like a container escaping its little sandbox, could potentially compromise the entire machine. And finally, at the very top, we have Kubernetes. It's the big brain that manages all of our containers. But while its complexity creates a huge attack surface, a publicly exposed API server, that's like leaving the front door to your entire operation unlocked. An account with way too many permissions, that's a disaster waiting to happen. So yeah, hardening Kubernetes is absolutely crucial.
So, why this intense focus on layers? Why all the fuss? Because when these layers fail, the consequences are very, very real. Let's take a look at what's really at stake here.
So, back in 2018, attackers found a Kubernetes dashboard at Tesla that had, get this, no password. You might be thinking, how does a simple mistake like that even happen? Well, it's usually about moving fast. A developer spins something up for temporary access, they get busy, and they just forget to lock it down. That one tiny oversight gave attackers a direct pipeline into Tesla's cloud, which they promptly used to mine cryptocurrency on Tesla's dime.
The Capital One breach is a masterclass in how one small vulnerability can become a total catastrophe. An attacker found a weakness inside a single web application container and used it to trick the server into requesting its own cloud credentials from an internal service. With those keys in hand, they unlocked a massive trove of sensitive customer data. It's just a brutal lesson in why we have to isolate workloads and lock down access at every single layer. Okay, with all that context, it is time for your assignment. Welcome to the team. You are officially a cloud security intern, and you have a critical job to do. All right, listen up. The Security Operations Center, our SOC team, has flagged some really serious issues. They're seeing containers running with way too many privileges, unsecured dashboards just like the one in the Tesla breach, and missing security policies on our core Linux servers. Your mission is to conduct a full security audit, pinpoint all of these misconfigurations, and then create a solid plan to get them fixed. Now, we're not just going to throw you in the deep end here. Your mission is broken down into these 4 very clear, very actionable tasks. You'll start at the kernel, move up to the containers, then hit Kubernetes, and finally, you'll map out the entire defense system. Let's tackle them one by one.
Okay, time to get to work. This is the part where you take all that theory and turn it into concrete, professional deliverables that are going to create some real security value.
Your first deliverable is this policy table. You're going to go through each server and document its security status. Is SELinux just turned off completely? Is AppArmor running in permissive mode?
That's a mode where it just logs violations instead of actually blocking them, kind of like a security guard who just takes notes but doesn't stop anyone. Your job is to find these gaps and recommend the right action, like switching from permissive to enforcing mode.
Next up, we're focusing on the containers. You'll use a tool, something like Trivy, to scan all the container images for known vulnerabilities, what we call CVEs. Then you'll produce this risk summary here, which is huge because it lets you prioritize the most severe vulnerabilities so they can get patched right away. This is a critical piece of supply chain security. For Task 3, you'll be auditing the Kubernetes cluster against industry best practices, like the CIS benchmarks. You're going to create a report that looks just like this one, pinpointing critical misconfigurations, like anonymous access being enabled on the main API server, classifying how risky it is, and detailing the exact steps needed to fix it.
And finally, you're going to translate all of your hard work into a single, powerful visual. This security architecture diagram, it's so much more than just a drawing. It's a communication tool. It shows everyone, from your fellow engineers to management, exactly how all our defenses, from the Linux policies all the way up to Kubernetes RBAC, work together as one solid system. This proves you don't just fix problems, you understand the entire security picture.
So the mission's done. What did you actually achieve? Let's look at the payoff from completing this mission, because it's big, both for the company and for your career. In a real internship, your performance would be evaluated across all of these different areas. And as this chart shows, it's not just about being good at one thing. Success means having a well-rounded understanding of the entire cloud-native stack, from the kernel all the way up to clear documentation and architectural design. Look, by completing this mission, you've done so much more than just fix a few problems. You've executed a full-stack hardening project from start to finish. You've proven you can analyze vulnerabilities across multiple, complex layers. And you've picked up a set of super valuable, in-demand skills. You've basically earned the title of Cloud-Native Security Engineer. And all this work really leaves us with one final big question. In these modern environments where services are constantly changing, scaling up and down in a matter of seconds, how can we ever really secure what we can't always see? This challenge right here is precisely why the principles of automated, layered security, built in from the kernel up, are more critical now than they have ever been before. Thanks for watching.